So, hello everyone, and welcome to this um, new video series on learning PHP object-oriented programming language. So, this is going to be an advanced series in which we'll be learning about this new approach in programming, in especially that's dedicated towards PHP. Now, PHP had been a very old language, but have it used to have that approach of procedural programming. Now we have seen many frameworks, and even the CMSs are arriving. The major CMSs that we know, or the content managements that we know, are known as the WordPress, the blogging CMS, then we have the Drupal and the Joomla, and there are many. Even besides having all these CMSs, we also have MVC frameworks. And for example, we have the Laravel MVC framework that have somewhat model view controller architecture or design pattern a that's different than when we use the CMS. CMS is somewhat like desktop publishing. It's far more easier for people who are not from programming backgrounds. Now, when we need to learn about this object-oriented programming approach in any programming language, this object-oriented programming approach, or OOP approach, is also implemented in many other languages. The language that has helped us to evolve this programming is the C, but the C had a major problem. It was procedural. Then we had the emergence of C++. Now we have over 200 programming languages. Many of them are specialized, many of them are generalized. One of the generalized languages that we have is Python. Now, the specialized languages we might also have, maybe, for example, we have the ActionScript. But the ActionScript, if you talk about the ActionScript, if you talk about the C#, which is used for Windows application development or Windows software development, or also for ASP.NET website development, this has the advantage of using this object-oriented approach. Basically, the fundamentals of object-oriented approach in any programming language is quite similar. There are some differences, but they are similar, but their differences mainly lies in part of the syntaxes. But we're not going to talk about what their differences are and how they're affected in different environments, in different perspectives. We'll be only focusing on PHP's object-oriented approach. Now, in this course of this video, I'm going to assume that you do have a working, or at least a basic understanding of a procedural approach in PHP, because this is really important when we want to understand how this procedural programming is transferred into an object-oriented methodology. Now, to understand what an object-oriented programming is, we need to first understand and relate it to our realistic examples, or our realistic object approaches. In reality, everything is an object. Everything can be represented theoretically as an object in a computer modeling. So when we try to use that computer modeling, we can exactly replicate what happens in the reality. Now, what we understand by objects are just things that has a definite mass, that occupies a definite volume, and we can touch them. Our laptops, our computers, our monitors, our books, our cell phones, our pens, our mouses, these all are objects. Even the cars that we own or we drive, the buses that we usually take, that we usually use for commuting to other parts of the city, or commuting to our work, or commuting to our schools or colleges, these all are objects. Exactly in the same way, we have shifted towards a more object-oriented approach in programming. When we talk about this object-oriented approach in programming, what we mean is we are exactly trying to create that object, uh, that we are exactly trying to replicate that object model in programming approach. Now, when we try to create an object, the first thing that we need is a plan. What is a plan? Suppose your house that you're living in, or you might be living in an apartment. It might be 5-story high, it might be 6 stories high, and there are apartments that are even 40, 20, 30 stories high. So these apartments had a plan. At first, they only existed in theory. They only existed in the theoretical designs of the architects. But later on, those designs were taken in by the builders, and they implemented and built your houses, your apartments according to that plan. And the first thing that we need to understand when we try to get into object-oriented programming is the class. A class is somewhat like that plan created by the architect. A plan is something, if you have seen how a plan it looks like in reality, if you see how the architect firms are designing, or they're doing all their calculations to create a theoretical model, you'll see that everything is in pen and paper. Everything is done on paper, and everything exists theoretically. They don't have any real existence. A class is somewhat like that in object-oriented world. A class defines a blueprint. A class also tells us how it also creates. By creating a class, we are actually creating a you can tell that we are actually creating a plan for our objects in programming. So in programming, your objects might be something like creating a template or a theme for your website, or it might be something exactly like creating a calculator. But behind that calculator, we first need to design that calculator. We can't really create that calculator without any working designs. So to create a working design, we need to have that class. So after that class is designed, or we have that design in our class, a class mainly consists of properties and methods. Now, methods and properties can be broken down, but we won't be talking about that right now. We will come to that point after we finish off with objects. Now, when we create that class, it only means that the entire plan exists in a theoretical sense. It does not exist in an objective sense, or in a realistic sense. So to build that according to the design, suppose we take that architect's plan. That architect's plan, we can name it as a class. It only existed on paper. Now, as a builder, what we need to do is to create the apartment according to that plan. So to create that apartment can be referred to as an object. So to create that object according to that plan, we first need to instantiate it. So this instantiation can occur in two different ways. So when we try to instantiate this object, we are actually we're calling the computer's memory, and we are allocating resources, or we are allocating memory for that object. So in reality, what happens when that architect creates that plan is that plan is a representation of what's going to happen, or what's going to be built in reality. That plan actually does not occupy anything. That plan does not show us how much volume it's going to take up, or how much that apartment building will take up if we are trying to build that on a specific land. If we have or we can't really say, unless we calculate it, we design it, we really can't say what sort of building or structure that it will be. Now, when we represent that same plan in object-oriented sense, we are saying that the class is a blueprint, but it does not really exist in memory. To make it existence, or to mark its presence inside the computer, we need to create the object using instantiation or statically declaring it. And these two approaches requires two different paths. One path can be used to allocate it inside a variable. We can use the instantiation process with the object operator to allocate or store it inside a variable or that we can name by ourselves. And in a different approach, we can actually take the statical, we can declare it statically. What we mean by statically declaring it is that we don't need to store this object inside a variable. So when we don't need to store that inside the variable, we can directly use the class name. Now when we try to create a class, we need to also provide a name for it. We can't really create a class without a name. So you can even see that every apartment, every house also has some sort of name for their identification. So we need to have that name, and we can use that name directly inside our code, and using the scope resolution operator, and that becomes the object, and that has a specific memory allocation inside our RAM. Now the class has two major building blocks. The first one is the properties, and the second one is the methods. So what we understand by properties is that they are actually similar to your variables. The main difference is that when we talk about variables, we are actually talking about a procedural programming sense. We are actually trying to use the variable independently inside the program. But when we talk about properties, it's the same variable, but we need to create that property inside a class. When we create a variable inside a class with special keywords, we actually called it a property. You can exactly do the same thing with the variable created inside the class that you would do with a variable that you created outside the class in a procedural approach. Now when we create a variable inside a class, we know it as a property, and it can be used using the this keyword scope, this keyword that defines the object scope. We'll be looking into real